Good morning, everyone. Welcome to MarkLogic World Tokyo 2016. It's my pleasure to be back here to speak with all of you. Many of you were here last year to speak with you again and share with you the phenomenal progress that's been going on in the marketplace, but also the progress that has been going on in MarkLogic. And one of the things that has really evolved is our focus on enterprise-class customers and enterprise-class data problems has really intensified, and we've started solving what I believe are some of the world's most complex data challenges that exist out in the marketplace. And one of the things that we realized as we started working at the projects and we started looking at the kinds of projects that we're doing is most of the projects that we do, not all, but the predominant workload is around data that's in silos. And as we've talked to customers and talked to systems integrators around the globe, what we have found is that the vast majority of corporations are struggling to manage data in silos. And it turns out that MarkLogic is absolutely the world's best database for integrating data from silos. And that's what I'm going to talk to you about today is what happens in data silos, why those are a challenge for businesses, and how we're going to change that trajectory by using a next generation database technology from MarkLogic. So if we're going to talk about databases and we're going to talk about what's happening in the database market, I always like to start with, well, let's talk about the underlying asset that we're trying to manage, which is actually data itself. And so we're going to talk about a few different varieties of data to try to help you understand what's happening in the data landscape. Then I'll move into the database landscape, and then we're going to do quite a deep look at what some customers have been doing with MarkLogic technology and how we solve these problems differently than the rest of the marketplace. So starting out with data, when we got into this new generation of technology, and I just passed my 4th year with MarkLogic about 4 or 5 weeks ago, and I made the same observation at MarkLogic World San Francisco that when we started out in this market, there was a lot of people that thought it was all about big data, and big data defined as large volumes of data, meaning a lot of data. And that is one of the characteristics of the NoSQL market, is that it does handle large amounts of data better than relational databases, but that's not the only thing it does, because if we look beyond that, the other characteristic that kind of went hand in hand with the NoSQL marketplace was, well, it's all for unstructured data. And interestingly, it does unstructured data extremely well, and we're obviously experts at handling unstructured data. But probably more importantly is that the vast majority of the world's data from a business perspective is actually very structured. And it turns out that NoSQL technology is actually very, very powerful for dealing with your structured data as well as your unstructured data. In fact, today, MarkLogic continues to lead in the next generation database market. We're the biggest company. We've been over $100 million in revenue for the last 2 years. And so we've established a leadership position, and the vast majority of the data that is actually managed in a MarkLogic environment today is actually a combination of structured and unstructured, but it would probably, the scales would probably tilt in favors of the structured data. And then there's this concept of open data. So what data is available to you publicly? What is available on different government websites? What's available from different public domains where you can essentially get access to other data sets? And you want to be able to use that data as well. So it's not just your data, it's other data that's publicly available, whether it be news releases, news wires, feeds, all different kinds of things. Geospatial data becomes very important. Geospatial data, why is that important today? Geospatial data is important today because virtually everybody in this room has a mobile device, and those mobile devices have location services available. So at the most simplistic level, knowing where you are at a given point in time can change your entire experience with the system, and it can affect what you're allowed to do. So geospatial data becomes very important. And let's not forget about mainframe data. We've been in the relational database era of technology for almost 30 years. So this is the first real challenge over the last several years that says there's actually a better way to solve data challenges with NoSQL technology. But if you actually go back and you ask yourself, how much of that old mainframe capacity on traditional IBM mainframes, how much of that capacity has actually been replaced? And the short answer is not very much. And it turns out from our experience is that it's very difficult to move from mainframe hierarchical databases into relational. But there's this notion of kind of generation skipping that says, I'll take my mainframe systems and my mainframe data, and I'll move that all the way to the NoSQL era. And I'll bypass the mainframe era altogether. And we've now done several major projects at very large corporations where we've actually moved data off the mainframe, moved the application off the mainframe, and then subsequently decommissioned or put out of service the old mainframe system for enormous cost efficiency for the clients. So when you look at all these different kinds of data, what I want you to think about from a data perspective is not, can I find a unique product for each one of these different kinds of data, but can I have a database solution that can handle all of that data, not just a subset of the data. So if we look at it from that perspective and say, okay, well, we have all this data, we want a database that can handle all the data, then the next thing that we need to talk about is, well, what's happening in that database market? And the database market, with all the new generation of technologies, is generally speaking been very confusing for most companies to sort through. In a very interesting way, Japan, because you're a little further off on the adoption of the new technology, you're going to be benefited by the learning experience that has taken place in some very complex markets. Because I can tell you, in a 4-year window of looking at a 4-year snapshot, what people thought was going to dominate the database world 4 years ago and what's actually happening today is completely different. No relationship. And one of the biggest changes is around what Hadoop is. And early in the Hadoop cycle, everyone thought, well, Hadoop's a database. And I think the vast majority of the market has now figured out that Hadoop is actually a great technology for bringing data together for analytics. And it is disrupting a $25 billion marketplace around data analytics. And that is what Hadoop is doing in the marketplace. That is its primary purpose. The vast majority of corporations that try to use Hadoop and do traditional operational transactional kind of workloads on Hadoop have failed and moved on. In fact, we have customers that I did meetings with 4 years ago who initially said, I don't really need to spend time with you. I don't have any projects for you because I'm going to run my business on Hadoop. In one case, the same individual that told me that is now our primary advocate in the same account. And she's the CTO of the account, and she has signed millions of dollars worth of orders on MarkLogic, being very complementary to the work they're doing with analytics and Hadoop, but building their next generation of business systems on a real database, not on Hadoop, which is really an analytics platform. Then you have the relational vendors. And the relational database vendors, Oracle being the biggest of them, have been out there essentially saying, we can do it all. And this is kind of a complicated space because when Oracle says we can do it all, you just put all your data in the Oracle database and we can do everything, technically, they are correct, with one caveat. If you have enough time and enough money to make that application work on Oracle, you can put all the data in Oracle and you can get there. But there's this notion in today's world about agility, especially in regulated industries, especially in highly competitive markets. And the question is, do you have 5 years and do you have millions and millions of yen to make a project work if there's a better, faster alternative? So the technology vendors, they tend to blur the lines between the different technologies. Then we have new relational products like Postgres as an example, which is open source NoSQL, or MySQL. which is an open source NoSQL, strangely owned by Oracle Corporation. And these products, perfectly good if you have a relational data problem. But you should not confuse new relational technologies with a new generation of database technology. It's a very subtle but very important difference, because the reality is a new relational product still brings along all the same requirements of data modeling and data preparation that a traditional relational database has. Then we have the open source database vendors. And the open source vendors, really their target was the web developer. The idea that says, I want to stand up something really quick, but by and large, the open source vendors, they did not pay attention to the enterprise requirements. It's one of the reasons a number of them have shown up in the Japanese market, and they've departed the Japanese market almost as fast as they got here, is because the quality requirements, the data availability, data security, all these requirements were largely ignored by the open source vendors. What they did is they built technology that allowed you to put data in, didn't necessarily keep the data perfect, didn't necessarily secure it, wasn't necessarily highly available, and then you kind of look and say, but most of you are from enterprise class accounts where you can't afford to lose data. You can't afford to have data inconsistencies. And so all of a sudden, these open source products, what I can tell you on a more global basis, they've largely run their course, meaning that people have experimented with them, people have played with them, and what I can tell you is a substantial amount of our business is now coming from projects that people attempted first on relational, then they said, well, I'll embrace a new technology, I'll go to open source, and now they've come back to MarkLogic, which is focused on the enterprise requirements in the marketplace. And then we have engineered systems, things like Exadata. The idea that says, we'll make your application really run very fast if you buy a very proprietary engineered system. And by the way, proprietary in this case, when we talk about Exadata, and expensive go hand in hand. So what they're really saying is, and in a funny way, the messaging around Exadata is, this is the modern way to run applications. And I guess as a technologist, I would disagree. I would disagree that the way to run modern applications is on very expensive engineered systems. That does not make the application or the underlying database, does not make it perform better, does not help it meet the business requirement you have. It does help the margins of the relational database vendors that offer engineered systems, because that is not how most modern companies are running today. They're running on very traditional Intel technology. And then we have this notion of what we call a Frankenbeast model. And I do not have any expectation that that translates well to this audience. So the way to think about this is think of about a model of complete chaos. And a vendor that exemplifies this is Teradata. Teradata has kind of come out with a model that says, we have our relational database, and then what they've done is they've bolted on about 20 or 30 different databases and database technologies around into this framework that they say, this is our simple strategy for solving big data problems around the globe. But what I can tell you is if you look at their map, what you'll see of their map of their strategy is it will look more like a map of the Tokyo subway system. Lots of different stations connected by different pipes, but not a unified strategy. And by and large, Teradata's revenues are reflecting this approach of our answer to modern technologies will be to bolt on to our core business a bunch of random technologies and try to sell it to you as here's a solution to your data problems. So essentially what's happened in the vendor world is we've made life kind of difficult on all of you as customers, because there's all this choice and all this new technology, and it all has a lot of marketing around it. And the reality is that makes it hard. You've got to choose amongst lots of different products. So what I'm going to try to do is narrow you down and explain to you where MarkLogic fits into this marketplace. And so our approach, very simply, is to solve modern business problems. And one of the biggest problems in modern businesses, from a modern business perspective, is I need a modern database in order to meet the requirements of my business. I need access to more information. And so that's what we're going to talk about today. So when we talk about solving problems, we look at it from a vertical perspective. We have a horizontal technology platform, but we think about what are the requirements in various vertical markets. And one of the big requirements in financial services is a complete change in the way regulators are looking at financial services companies, at banks, at credit unions, at credit service companies, all the different elements for all the different asset classes that banks typically and financial services companies typically deal with in their trading environment, in their banking relationships and other things, is regulation. And the reality is the regulations are changing continually, and that becomes very difficult. In a funny way, in most parts of the world, the regulators actually suggested that different parts of the bank should run independent of each other. But now, after the credit crisis and after some worldwide economic challenges, now they're kind of saying, well, we want to look at the banking industry from a consolidated viewpoint. So all your separate systems now have to have a common view, because if they look at a financial services company or a bank, they don't want to understand the risk or the credit, essentially credit coverage for each of the individual asset classes. They want to look at risk from a consolidated perspective across the portfolio from the financial services company. So regulatory change has really driven this industry. There's also a big change around knowing more about your customers and fundamentally changing your customer experience in banking. Healthcare. Healthcare has changed dramatically around the globe. And one of the concepts that's really emerging is, can I go see a doctor across an internet? Can I have a chat room session? Or do I actually need to, when I'm sick, not feeling well, get in my car and drive to see somebody that I could actually have an electronic experience with? But if we're going to enable an electronic experience, what do we need to know? Well, we need to know everything about you. We need to know who you are, how old you are, what your underlying medical issues are, what medications you're on. We have to collect lab reports and information about you. And we actually have to conduct some transactions to say we might send you to another lab for another test. We might have somebody come to your home to treat you. But I can only do that if I actually have all of your data as a patient. So all of a sudden there's this need for a 360-degree view of you being the patient being treated by a medical establishment. The same thing's true, by the way, if you go into a hospital. Typically in a hospital, the likelihood that they have access to your medical records is very, very low. It's even lower if you think about the perspective of an ambulance showing up to help you with your particular medical challenges. The likelihood that those individuals have information about you is very slim. So we need to make information flow more freely if we want to fundamentally change the way healthcare is delivered. Media and entertainment. Media and entertainment industry has gone through a massive change over the last 15 to 20 years. And I think it's finally stabilizing. There's been a lot of consolidation in this marketplace, but one of the fundamental changes is we move from print media to a digital experience. And we've also moved to a digital experience that is multi-device. So generally speaking, if I have content, I'm a media company, I'm a publishing company. If I have content, what do I want to be able to do? I want to be able to send that content out to you, to your mobile device, to your tablet device, to your laptop, to your desktop, and to your TV, and have all of those, particularly delivery mediums, coordinated. So you can actually know and see the information you want at any given time on any given device that you want to operate on. Fundamentally different digital experience around the media and publishing industry. And I could go on and on through industry after industry after industry. I'll talk about a couple of them here. Energy industry. The energy industry, in particular oil and gas, has gone through dramatic change over the last 24 months, predominantly driven by a massive worldwide reduction of oil prices. So all of a sudden, oil companies that were flush in profits because oil prices were very high are now retrenching and trying to reduce costs very dramatically. We did a very interesting application at one oil and gas company, a very small one called Chevron. Not exactly small, very big global provider of oil and gas. And they did a very simple application, and that was to take all the information on a refinery, create a digital experience in a MarkLogic database, and from that digital experience, what a mechanic could do is they could go to an electronic system from their tablet or their mobile device, and they could find diagrams, electronic diagrams of any part of a refinery and identify part numbers based on what refinery they're working at and what components they're looking at. And on average, that application, this was one of the presentations at MarkLogic World in San Francisco, on average, that presentation saved 1 hour of time for every mechanic at every refinery around the world. So here's a project that was a relatively simple next generation database application that is saving Chevron millions of dollars while oil prices are in decline. I could go to life sciences. We could talk about clinical trials data. What happens with all that data during a clinical trial of a new medical device or a new drug? Are they really processing all of that data? Go to legal field. The legal field, what's it all about? Contracts and documents. Can you and your companies and can your legal staff in your companies today actually know what your legal obligations are at any given point of time with any given supplier or partner you might have in your business? We've actually been working with one of the financial services company building an application to legal document repository so that when they have a company goes bankrupt that they're doing business with, they can in seconds know every relationship that bank has with that particular entity. Again, why are they doing that? They're trying to drive down the time lag before they can respond. They want business agility. So if we put all this together, what customers really want and what businesses really need is they need a 360-degree view of their data, a unified, actionable view of that data. So unified, I think a lot of people understand. Unified is I bring it all together in a common place so I can look in one place and I can see all my data. The actionable side is, as business people, what you want to do is you want to actually change your workflows and you want to change your business processes and you want to do something based on that unified view of the data. You want to change your business processes, change your workflows, do new kinds of transactions against the unified view. So it's not just to look at, it's to actually use it to run your business. But the reality is the data is in silos. It's in many, many disconnected databases. If I go to the regulatory environment, I go into a typical financial services sector, I will find hundreds of databases. If I go into a healthcare field, I'll find hundreds of databases. We have a healthcare insurer in the US. They had 140 different systems that were just for their HR department. So they could know anything about any employee at any given time once they went and queried 140 different HR systems. So the data is in silos. It makes it very difficult. So what happens if the data is in silos? Then what we do is we spend a lot of time and a lot of money trying to solve the data in silos problem. So the typical data scientist who's trying to analyze business data is spending about 80% of their time simply bringing the data together into a common repository so that they can actually look at the data. And then we have this notion of ETL processes. And 60% of the cost of a data warehousing project is spent on the ETL processes, which is the extraction, transformation, and load process. The idea of trying to make all the data look the same so I can bring it all together and I can evaluate that data. And the net result of it is billions of dollars of money being spent creating silos. A lot of the silos are being created because of a limitation of the relational architecture called the schema. So, why does the schema and why do relational databases have this challenge? Is because they describe all the data. They describe all the data as in a fixed schema. And so what ends up happening is the technical challenge for all of you is that relational databases with ETL, they give away the agility, the timeliness, and the cost. But why is that? The reason is because when you're doing an ETL project, you kind of have to know everything you want to do with the database up front at the time you write your transformation processes, because it's very cumbersome to change those transformation processes later. But what happens if the source data, if I'm bringing in 10 databases and I'm ETLing them into one new database, what happens if one of the 10 databases change? You have to rewrite your ETL. What happens if, let's say you're in a bank, and the regulators say, thank you for answering this question. Can you now ask the data this question? In other words, you have a new query. What happens in a relational database? I have to reindex the database specifically to the query I'm running in order to get good performance. So essentially what you have with ETL is you have a database process that says anytime the structure, the format, or the source of the data changes, I have to rewrite the transformation. So I always have to rewrite everything every time something changes in my business. And then secondly, what happens is every time I want to ask the data something different, I have to create a specific index against the database to make that query efficient. And then we do that over and over and over again. So an endless loop of ETL. So what's the desired solution? A database that integrates data better, faster, with less cost, and doesn't have the same DBA burden of continually reindexing and reorganizing a database. And that alternative database, that is the MarkLogic alternative. We are a NoSQL database, but we're a NoSQL database with a few qualifiers. First of all, we're enterprise. Secondly, we build operational and transactional systems in the MarkLogic environment. Just like you would have built operational and transactional systems on the mainframe, or just like many of you might do today with DB2, with Sybase, with Oracle, with the relational databases that have evolved over the last 30 years. No other NoSQL product in the marketplace is focused today on giving you operational and transactional capability. So what is it that we do differently? Well, first of all, we make the data very easy to get the data into the database. We use a term, we say, ingest the data as is, which means you ingest the data without transforming the data. And by the way, we can ingest all of your data, your structured data, your unstructured data, your metadata, your geospatial data, your social media data, any data you might have that's relevant to the application you're trying to build, we simply ingest all that data in. So we make it with a very flexible schema architecture. We make it very, very easy to load data into a MarkLogic environment. That's good. That solves the ETL problem because now as data changes, I don't transform it. I just load more data. Very much the way Google today, when you change your web pages, nobody rewrites Google. If Google had to rewrite Google every time one of your web pages changed, we wouldn't know who they are. They'd have millions of people doing nothing but that. So what do? They just index it all. Well, guess what we do with your corporate data? We index it all. So as that data is coming in and we ingest it as is, we create a universal Ask Anything index. Very similar to the way Google would do it for web pages, we do it for corporate data. Difference is we store it in the database. We are a database. We're not a link out to the web page. And so what do? Easy to get it in, so we don't make you have a fixed data model. Very easy to get it out because we have a universal Ask Anything index. So I index the data once. And once I've indexed the data, I can ask anything of the data. I don't re-index it every time the question changes. So I don't have that DBA task of continually re-indexing the data every time a business unit builds or deploys a new application or comes up with a new ad hoc query. And then lastly, when we say we're enterprise, we're talking about 100% trusted. So trusted transactions, disaster recovery, full disaster recovery capability, full data consistency, and something that's critically important is a really solid government certified security model in the product to make your data secure. If you're bringing all this data together in one place, you certainly want to be able to secure the data and manage who has access to what information. And that is something the transactions, sometimes referred to as ACID support, the transactional capability of NoSQL databases, these are capabilities that the other NoSQL providers just said, yeah, none of that's important. We're not going to worry about that. And the reason is because they thought it was about the flow of the data, the structure of the data. They didn't think about it from a systems developer perspective that says, I have to build an application, and that application is operational and transactional. I am updating it, and I'm distributing data around the globe, and I'm keeping everything 100% consistent, 100% of the time, and I'm making it secure. And that's the MarkLogic alternative. So what I'd like to do is talk to you quickly about a couple of examples where we've actually done this. And one of them is Deutsche Bank. Very large global financial services company, operates in almost every part of the world. And what we started working with Deutsche Bank on a couple of years ago was actually transforming the way they do trade processing. And so it's not a matter of, gee, we're just going to build something so you can look at trades. We actually are transforming the trade processes. And what was going on at Deutsche Bank is on the left side, they had over 30 different trading systems. On the right-hand side, they had the need to do post-trade updates, amendments, and corrections. So think of that as post-trade transactions. They also had an ongoing and shifting requirement from the regulators that said, we're going to ask you multiple different questions. Deutsche Bank happens to be one of the banks, unfortunately, that it has been a very heavy recipient of very, very large fines for billions and billions of dollars. And so all of a sudden, they now need this ability, and one of the reasons they were paying a lot of fines is because they had inadequate capability to actually meet the regulatory inquiries that were necessary, and they couldn't really look at their data to know what did we actually know about a given transaction. So instead of knowing about it, end up paying fines on it. So what they tried to do is they tried to create this unified trade store, what they call a global trade store. Bring the trading data from 30 different trading systems in, put it in a single repository. And they spent 2.5 years trying to do that with Oracle. That was their database standard at Deutsche Bank. And after 2.5 years, every time one of the trading systems changed, they had to rewrite the ETL processes. And after 2.5 years, every time the regulator said, that's very nice that you answered these questions, can you please answer these other questions? They had to re-index the database. And they were in an endless loop of not getting it done. So they finally brought in MarkLogic. And what we do now is we ingest all the data as is. We ingest the trading data. If one of the trading systems change, that's just more data and different data coming in. We index it all with the universal index, and they can run any regulatory inquiry against that data that they choose to run. So what was the result? The result is this trade store, after a 2.5-year attempt to not finish the project on Oracle, went production in 6 months on MarkLogic. We're talking about agility. It's very flexible. If the trading systems change, they don't have to rewrite it. It's extremely cost efficient, runs on scale-out Intel architecture. And they use a term when they talk about enterprise requirements, because they tried products like MongoDB and others beforehand. They experimented and played with those products, but they said, those products are interesting, but we're running the bank on MarkLogic. Running the bank is the enterprise features. They're doing transactions. The data is secure. The data is highly available. The data is replicated around the globe. They're meeting their regulatory requirements. And by the way, we're working today. We're very far along on another trade store that has 42 different sources of data going in. So completely changed the speed at which Deutsche Bank can build and deploy new applications. What about another industry that's gone through transformation? In particular in the US, we have this thing called Obamacare. It's healthcare.gov. This was essentially creating a marketplace for healthcare policies. When the legislation passed,